Hi everyone, so in this lecture we are going to discuss a new property of a Laplace transformation. So that property is prove that Laplace transformation of sine hyperbolic at is equal to a divided by s square minus a square. Now with the help of definition of a Laplace transformation, we have already discussed this definition in lecture 1, that is Laplace transformation of f of t is equal to integration is 0 to infinity e raised to minus st into f of t dt. Compare this LHS, that is f of t is equal to how much? Sine hyperbolic t, that is here f of t is equal to sine hyperbolic at, and when we try to convert this sine hyperbolic t into exponential form, so that form will be e raised to at minus e raised to minus at divided by 2. So this is possible because of this is my sine hyperbolic t and it has a function that is a e raised to, there is a t, that is e raised to t minus e raised to minus t divided by 2, and with the help of this formula this sine hyperbolic at is converted to this formula. Okay? So this is your new f of t. Now put this value of f of t, that is this is new f of t, in place of here. So this equation becomes Laplace transformation of sine hyperbolic at is equal to integration 0 to infinity, first term will remain as it is, that is e raised to minus st into this sine hyperbolic, that is f of t means sine hyperbolic at, and sine hyperbolic at is now converted into exponential form. So that implies e raised to at minus e raised to minus at divided by this 2 into this dt, that is here we can write it as a dt. So this is your new integration. Now solve this integration. Here 1 by 2 as a constant, take it as a outside element, that is 1 by 2 into integration of 0 to infinity. Now multiply e raised to minus st into e raised to at. Take a minus sign as a common element, that is minus in bracket s minus a into t. This is our first element. Middle term is a minus sign, so minus. Second term will be e raised to minus st into e raised to minus at, that is e raised to, take a minus sign as a common, that is minus in bracket s plus a into this t. So we have obtained this product as like this into this dt. Now solve this integration one by one, that is 1 by 2. We can put here a curly bracket. Now solve this integration, then we get e raised to minus s minus a divided by this coefficient of t, that is minus s minus a, and put its lower limit and upper limit. Here we have a lower limit as a 0 and upper limit as a infinity, minus, now solve this integration, that is e raised to minus s plus a into t divided by this coefficient of this integration, that is minus s plus a, and it's a bracket, and similarly after solving the integration put its lower limit as a 0 and its upper limit as a infinity, and close this curly bracket. So we have obtained right now, that is 1 by 2 in curly bracket, put infinity in place of t, that is e raised to minus infinity divide by this first term, that is minus s minus a. Similarly middle term is minus, again put 0 in place of t, that is e raised to something into 0 is 0, that is e raised to 0 is how much, 1, divide by this minus s minus a. This is our first bracket. Again middle term is minus sign. Nextly second bracket will be put infinity in place of t, then we will get first term as a e raised to minus infinity divide by this term, that is minus s plus a. Middle term is minus sign, and nextly put this 0 in place of t, that is e raised to 0 is 1, divide by this term, that is minus s plus a, and we have completed this bracket. So after putting upper limit and lower limit in place of t, we have obtained this bracket. Similarly in second bracket after applying this upper limit and lower limit, then we have obtained this bracket. So now check, e raised to minus infinity is equal to how much? 0. So first term will be 0. Similarly, third term, e raised to minus infinity is equal to how much? 0. So 0 upon something is again a 0. So this first element and this third element will be a 0, and remaining element is 1 by 2. This minus into minus, that is plus, so 1 upon s minus a, this sign is minus, again minus minus what? Plus, so 1 upon s plus a. So this is your last step. Now to obtain its Laplace transformation, just to solve this bracket, that is do one thing, that is a cross multiplication, that is 1 by 2 into this s plus a minus s minus a into 1 is s minus 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 plus a, divide by this s minus a into s plus a. So s minus a into this s plus a, and complete this bracket. Now check, this s and this minus s will get cancelled to each other, then remaining term will be 1 by 2 into this a plus a as a 2a, so 2a, divide by s minus a into s plus a is equal to how much? S square minus a square, and after cancellation of 2 and 1 by 2, then we will get it as a divide by this s square minus a square. So we have obtained this formula, that is a divided by s square minus a square, which is nothing but this. That is, now we have proved that Laplace transformation of sine hyperbolic at is equal to a divided by s square minus a square.